Hello mates, welcome back. This is the Unemployed Geek, and today we are going to dive into one of the most powerful algorithms in the world of algorithms, and that is breadth first search, or BFS. Whether you are building a pathfinding system, or you are solving mazes, or navigating social media networks, then BFS is the algorithm that gets your job done. So what exactly BFS is and how does it work? Imagine you are standing in a network of friends and you are trying to figure out the shortest path to reach someone on the other side. BFS can help you by visiting all your direct friends first, then their friends, and thereafter friends of those friends, level by level, until it finds your target. Let's break it down in terms of a tree structure where BFS can be explained properly. Have a look at this. You can think of each node in this tree as a starting point, and every connection is a branch to other nodes. BFS start at the root node 0, a starting point. BFS uses a queue to keep track of the nodes to be explored. Starting with the root node, it enqueues it and then explore all its direct children or neighboring nodes first. Once those are explored, BFS moves to the next layer, processing each child node's children's level by level, or breadth wise. That is why it's called breadth first search. This process repeats until all the nodes are visited or you have found out what you are actually looking for. By visiting each level of nodes before moving deeper into the tree, BFS guarantees that we will find out the shortest path between the root and the targeted node. Now let's take a look at some real-life examples where BFS is used effectively. Think about social media networks like Facebook or LinkedIn. When you are searching for mutual friends or the shortest connection between two people, BFS comes to the rescue there. It helps by exploring the shortest path, like Ram is connected to Sam, who knows Sita and who is connected to you. In this case, all direct friends will be checked at a first position before moving to their friends of friends. Another example can be a GPS navigation system. When you are driving through a city and looking for the shortest route without any weights like traffic or speed limits, BFS can help you by exploring all the intersections and streets level by level until it finds the destination. BFS is even employed in network broadcasting or multicasting to find the shortest route for data transmission across the nodes. It ensures that messages are transmitted through the shortest possible path in peer-to-peer networks like torrenting protocols. There, BFS ensures that data is shared through the shortest, most direct route across the nodes, helping the data reach the entire network quickly. BFS is even used in applications that search for nearby facilities like hospitals, police stations, or fire stations. When you use a service to locate the nearest emergency response unit, BFS explores all locations closest to your current position before expanding the search radius. Even in programming language like Java, where garbage collection is there also BFS used for preventing memory leaks by cleaning up the unreachable objects. Finally, The example you have already seen at the beginning, that is a very good example of solving mazes and finding the shortest path puzzles where BFS is enforced. So now let's jump into how we could make that using Tkinter GUI so that it could be more responsive, and let's bring BFS in the action. Let me give you an overview. In this game, the matrix will be created with random integers, and odd numbers will be the blockers in that matrix, and the even numbers will be walkable. So now let's jump into the code part. Now let's implement this, but before that let's install Tkinter, which is a popular library to make the GUI in Python. For Windows you can simply use pip install tk, but for Ubuntu we can install it as a apt package. So this is done here, and let's go inside the project directory and let's activate the environment, Python environment. So if you want to know how we could create and use Python virtual environments, you could refer to my another video which I have already uploaded. I will give the link in the description so you guys can check that. So let's move forward. Let's create an empty file and let's name it shortest path game.py. Let's open that in VS Code and let's import the necessary libraries one by one. Then first thing first, let's define a function for BFS algorithm as BFS search, which will take two tuples as an argument, and these tuples are starting and the ending coordinates. Then first define matrix as a global variable, then assign values for rows and columns of that matrix. Put the row, column and destination inside a queue. Declare a variable visited which will be a set, and add the coordinate in that set. Declare a dict parents so that if the end is found, the path can be reconstructed. So main BFS loop starts from here and it will continue until there are no more nodes in the queue, while row, column, dist equals to queue.popleft. The popleft operation retrieves and removes the first element in the queue, giving the current position and the distance. If row, column equals to end of 0, end of 1, return true, distance and parents. If the current position matches to the end position, the function will return true, the distance to the end and the parents mapping, which can be used to reconstruct the path. The four possible directions to move up, down, left and right are defined. For each direction, it calculates the new coordinates for D row, D column in. Now let's check if the new position is within the bounds of the matrix has not been visited yet, and whether the value in the matrix at that position is an even number. If these conditions are met, then the new position is added to visited. Its distance means current distance plus 1 is enqueued, and its parent is recorded in the parent's dictionary. If the loop completes without finding the end position, the function returns false, indicating there is no valid path exist, along with -1 for distance and an empty dictionary for parents. Now let's define a function to create matrix. So let me declare the global variables which will be used across the script. Now let me define another function so that I can make the matrix fit to the screen for bigger size of matrix. Let's name it as adjust window and cell size. It will take two arguments, row and column. Then let me define global variables. Screen width for width, and screen height for height. Let's call that function inside create matrix. Now let's create a random matrix and let's check if the path exists as I want to make odd numbers as obstacles, and let's ensure that there must be a path till the end, or the end cells are not blocked by the odd numbers. So let's define a function to ensure the path is exist. Let's call the BFS search here and store the value. Return found. Path exists function here. Then let's draw the matrix. Create another function and name it draw matrix. This canvas is basically a Tkinter object. And call that function there to draw the matrix. Now let's define a function and let's name it guess shortest path to prompt the user guessing the shortest path in the Tkinter GUI and run the process further. To get function find the shortest path, let's define a function and let's name it find shortest path to get the shortest path,
which we are going to call in the else part.
If the starting and ending coordinates are blocked by the odd numbers, then we have to go for the next position available, means where even number will be there. So let's define another function to find the next cell and let's name it as find next cell. Let's call that function here. and call the BFS search to get the shortest path parent. If it is found, then let's draw the path. So let's define another function which will draw the path. Call that here. And let's define the Tkinter messages. Now let's design the Tkinter GUI. We are done and let's run it. So this UI is not looking that good because we cannot find out the blocks properly. So let's change the script a bit, where I have defined the draw matrix function, and let me change this outline color as black. Let's run it again. Now it's looking good.
So now let's count the steps, and it is 7 minus 1, 6, and let's go for a bigger matrix of 10 cross 20. And let's count the steps for this also. And it is 31 minus 1 is 30. So that is it for today, and hope you guys have enjoyed this one. And if you find this video informative, then please do like and subscribe us to support. So thank you. We will come back with our next video. So till then, bye bye.